Okay, welcome everyone. Today we're going to go through our propeller design revision 1. What we did last time was we did the trim style propeller where we made a curvature and we made two shapes as a surface and used like a cookie cutter method, the trim method, to make that curvature, and then we repeated that as well. Instead of using surfaces this time, we're going to be using an aerofoil sketch. We're going to be setting up planes and using the core function will be a loft function, what they call a loft, okay? So our learning intentions, this is a more advanced process. We'll be getting our heads around that. There will be some common elements. There will be some new things for you to learn as well. Also, what we're doing here is we're trying, you saw the experiment we did before when I ran this compared to some of the earlier designs. We could notice that this design went a bit further, okay? The main reason that went further is because we're harnessing angular velocity as a concept and incorporating that into our design, okay? I'll unpack that in a little bit. And what we need to do here is focus on the accurate recording of our data as well, okay? So that'll be more a direction and not something that I'll incorporate into the video, but it's something that we'll be looking into. So the tools we'll be using, things to keep your head out for, sketching and extruding will be the same. That'll be for our core part, that'll be the same there. We'll be using pattern repeat the same way we have before. Lofting, filleting and finishing will be the main differences here. So the loft is where you set up 3 sketches in 3 parallel planes. You can add more if you want. If you do a loft between 2 planes, it'll be a straight kind of curvature between the 2. If you do 3, it'll average out 4 and so on. When we do aerodynamics next year in our aerofoil design for our wings, we'll be using lofting again, okay? So our success criteria here, you should be generating more thrust from this propeller once it's done. As before, won't be too thin and it will be 3D printable, and you'll successfully be able to achieve these new functions in a stable 3D model that's printed out. Okay. So let's switch over to our tutorial. I'm on the right screen. Good. Okay, so this is our corporate propeller car model that you would know from before, and this is the one we've edited with, made our manufacturing plans. You've all built off this file. This is what was copied out to you. What we will end up with by the end of this tutorial is a model that looks a little bit like this. Now, when I look down from the right plane, this is the main thing we're trying to achieve here. We're trying to achieve that curvature. Okay, that curvature is at a consistent rate, meaning that there is a set angle for the first sketch, the second sketch, and the third sketch. The angular difference between those 3 sketches is the same. And I think it's about 15 degrees, if memory serves. Okay, so essentially what we're going to do is get one sketch, copy it, and repeat it a bunch of times. Okay, so as before, we'll focus on making one propeller blade. And then we'll repeat it, and then we'll make our central axle and everything like that. We can also add other elements to trim that out to make it all fit. I like to make this as small as possible to strip out as much weight from our propellers too. You'll also notice that it's quite thin. When I printed this out, I had to print it at a really low high resolution to make it a bit more stable. All right, so let's get into it. So going back to the same thing that we always do, we're going to turn on our origins. I'll get rid of my navigation panel so we have the full screen. And what I'm going to do is I'm going to model out this way, and as always, I'm going to work from the origin out. Okay? I'm not going to do a construction box or a construction circle this time because I can set my planes to, be the length that I need them to be. So does anyone remember our parameter for our propeller blade? Axel?
It was 70 by 20 by 20 by 20 by 20.
Yep.
So 70 in the center.
Yep. So 70 mils is our length. Yeah, but yeah, lots of detail there. That's great. We'll be going well within that for the 20 by 20 constraint, but we'll be going to that full 70 millimeter length. Okay, so I'll firstly set up my construction sketches. Okay, so I need to make planes. I've got a core plane here. That's part of my XYZ plane, and I need to offset that. Okay, so what I need to do here, half of 70 is, thank you, 35. I'm going to make a plane at 35, and then I'm going to go in construction plane offset to 70. Okay, so that's the first thing I need for a loft. These three things. Now, if you have a Mac, I'm going to be using an add-on that you won't be able to use, I'm sorry, but you still can make this sketch of an aerofoil fairly easily, okay? So what I'll do here is I'll add a new sketch to this plane, and I'll go down to create airfoil. It doesn't, you could do it, you could reference it from the original plane and go 35 and then 70. You could go 35 and then 35. Doesn't matter. Yeah. So I'm using NACA profile 0010. That's my favorite. It's pretty like symmetrical. And points per side, I'll put in about 12. Okay, it does weird things. So what it does is actually puts in this sketch here, and you'll see how it's like straight lines, yeah? But that's an aerofoil sketch. What we'll do is we'll actually we'll turn this into a construction sketch, and we'll trace over this with the spline tool to kind of smooth and average out those points. No, I'll show you the loft. Okay. Axel, leave the questions for the end because I'm recording, okay? Yeah, I know you have lots of questions. So what I'll do here is record, I'll edit this, I'll copy it, and then I'll paste it and resize it and all that stuff, okay? So I'll also show you ways that you can make this yourself without using the aerofoil module. It's not essential. But if you can pretty much make that curvature, you can make an aerofoil, okay? So I will select all of this. Sorry, I have to activate the proper sketch. So that's the sketch. I'll go edit. I'll select it all, and I'll go copy, and I'll go finish sketch. I'm not actually going to use this sketch in my modeling. Okay, and I'm going to start by pasting this down to my first plane. So my first construction plane is here. So what I'm going to do straight up is go Control V, paste, and that will put down that sketch for me, okay? I don't necessarily know the size of it just yet, but I'll do things like put in that bounding box and things like that, the construction box, to size it properly, okay? I want my propeller to rotate initially at 45 degrees. So I started at 0, and I want to go to 90, and then I want to go 45 degrees past that. So I'll be rotating to 135 degrees. And I'll go OK. And what I'll also do here while I'm on that sketch is create a center rectangle, the construction line, to size out the size of my propeller, okay? So I'll make that 20 by 20, but I won't go all the way to the edge on that one. Okay. After I'm done with that, I'll go back to select. And what I want to do here is now place this sketch over the center. and I'll go modify, move. So I can grab this and move it freely. Whoops. The one mistake that happened there was I picked up the origin as well, so I'll go shift and unselect that origin. Actually, sorry guys, I'm going to backtrack just a little bit because I want to get this placed first. I'll edit this out in the video. So I'll rotate that to 135. I'll move that over the center. Doesn't have to be exact. I'm just eyeballing it essentially now. And then there. I will change this into a construction line. So I'm hitting this little toggle here, and that's now a construction sketch. Okay. In a separate sketch this time, I think, just to kind of alleviate the problem I made for myself before, I'll add another sketch here and put in that bounding box, not connected, if that makes sense. Sorry? I'll show you. Cool. So 20 by 20, finish that sketch, and then I can go back into my sketch one. I had a little problem for myself there because I'm going back into a sketch that okay. I just dragged sketch one in my timeline in front of sketch three. Just a few of those little things that kind of a bit niggly and annoying. I'll do some fine adjustments here. Go move copy. That's fine. And I will select this sketch again and scale it. And when I scale it, I'll scale it around that middle point there. So I'll go sketch scale, point, select. I'll grab this slider to scale up. So I know that when I do that, it's fitting inside that 20 by 20 box. I'm going to pick somewhere that's kind of in between. And I'll go okay on that. I'll just make it twice as big. So I'll just put in 2 as my scale factor. And this is where I actually get to make the proper sketch that will be 3D printed or 3D modeled. I'm going to go to my spline tool, and I'm going to use these points in my construction sketch as the basis for that spline sketch, if that makes sense. I'm going to start and finish at the tail. So I'm going to go all the way around and back to the tail. So all I need to do here, it's really simple. With my spline tool selected, I'm just clicking on these points that I've dropped for myself. And what it's doing is creating a nice curvature. So see how at the tip of the propeller blade, it's made a nice smooth curve there for me. Back to the start. Awesome. Now, this part here is a little bit strange. So what I'm going to do is edit the back part of this sketch. So here, I'll go to select and just bring in this little toggle here until it's kind of sitting around the construction lines I've set for myself. What I'm going to do is use my trim function. I'm going to add a little arc at the back here. I'm going to trim off the back of this propeller blade and just put a little round here so it's a bit more 3D printable, because that's one of our success criteria. So what I'll do here is just draw a line. I know it's at 45 degrees. I know my whole sketch is sitting at 45 degrees, so I'm happy with that line there. And then I'll use the trim function and trim out the bits of the sketch that I don't want. I'm using this like a rubber that out, that, all this, okay? And you'll notice that's opened up my sketch. So I've got an open end, and it's changed from shaded blue to just a line. So in order to make that 3D printable again, I need to go in and close that sketch up. And I'm going to use an arc between these 2 points. So it's a tangent arc. So between here, make sure I've got the right points here. Notice how as soon as I've done that, it's turned blue again, and I'm good to go. All right, it's very, very, very small what I've done, but that little round will make a difference, okay? And look, if it doesn't print properly, I'll go back and redesign. I'll cut down here where it's a bit thicker, and that could be fine. So that sketch is what we will use. You can do all kinds of things with this one core sketch. So what I'll do is I'll go here, select it all, Control-C, copy, and I'll finish that sketch. Now, my job here is to get this sketch pasted onto these other 2 sketch planes, okay? So this is where I talk about angular velocity. If this propeller blade here is rotating, we all have that basic understanding now that we're Year 9 students, that if this thing's rotating at a set rate, so a certain revolution per minute, we know that it'll be traveling faster at the tip of the blade compared to the center of the blade. Okay? By how much, we don't really know, but we understand that concept. Okay? So what I can reasonably assume, if this is moving slow and this is moving fast, it's going to be interacting with the air differently. So all I'm making here is a hypothesis that because this is moving really fast at the outside, it's going to be creating more drag if I'm not angling my propeller to, move the air efficiently. What that angle should be, what that optimum angle should be, I'm not sure. That could be a subject for your experimentation. So to iterate on this propeller, we're going at a curvature rate of 15 degrees. You might want to change that to 10. You might want to change it to 5. See what the difference in performance is in your different propellers, because that is a valid experiment. All you're doing is changing the design of the propeller. Okay, I'll answer questions at the end. So what I'm going to do here is sketch onto this one, paste that sketch. When you copy and paste a sketch, it should go in the exact same position, so it makes it really easy for us. But all I'm going to do here is just click once on this rotation thing and type in 15. It's gone the wrong way, so I'll put in a negative 15. Okay, and the point of rotation is off, so I'm going to do that again. I'll undo that. I'll paste. I'll set my pivot as the center here. I'll go OK. Then I'll do the same thing, negative 1, 5. I'll go OK. All right, so you can see how this curvature is gradually changing, the rate of curvature between these 2 things. I'm going to finish that sketch. I'm going to go onto here. I'm going to add a new sketch. Control paste. Control V. Set my pivot as the center. When the bell goes, please, I know we're running out of time, just stay where you are. I'm going to go here. Negative 30. Guys, wait. And finish sketch. Now what I'll be doing is a loft. The loft is just up here. And what you're going to be doing is just selecting the 3 sketches that you've put down. So 1, 2, immediately it'll start to generate form. 3. And then OK. All right, what I'll do now is pause and I'll finish recording after the bell goes, so we have a bit of quiet. And then I'll put up the rest of the video after this, okay? Okay, so just back after pausing while everyone left. So we've done that loft pattern there. Okay, that's 70 millimeters between here and here, and we can see that same curvature here. Now, if you wanted to go in and change this, if you want to go and say run an experiment on what kind of angular change you make between different sketches, all you need to do is go in and go move copy, set your point as the same, set it as the middle there, go OK, and then you can change this same sketch forward or back by increments of 5 or whatever you want to do. Okay, so it might be changing it back by 5 is the right thing to do, but what you'll notice is here that change is reflected in the model as well. So if I go back, you can see that change is reflected. So that's what parametric design should be doing, simple changes to test specific things. Okay, so one thing I know will happen is this is very wide, so I want to be able to trim this in a little bit. So I'll go and do that now. So what I'll do is actually, yeah, so what I'll do is I'll go here, sketch, and I'll project this side of the sketch so I have a reference. I can't get the full back edge, but what I'm going to do is pretty much just draw a curve that goes like this. So I'll have a circle that maybe starts here and then, you know, cuts off a bit of that. So I'll make a circle. I'll make a 2-point circle. I just have to find the right distance to keep it from that end of that propeller there. So 2-point circle, I'll go in here. Good, that's what I want. Okay, so I'll line that up. And then I will put another box over the side of it. And what I'm going to do essentially is make an extrusion, like an extrusion box, but it'll be for cutting and not adding form. So I'll go in, I'll strip out the bits of the circle I don't want. Cool, cool. So really all I'm going to do is take this part here. I'll grab that. I can delete that central part, hopefully. All right, I'll finish that sketch, and then I'll run a simple extrusion in 2 directions. So I'll go here, here, and here. I'm holding down Control. So click 1, hold down Control, 2, 3. Then I'll hit Extrude. Instead of one side, I'll go symmetric, and I'll just drag that up. That will just turn into a cut. Okay. Now I'm ready to do my pattern repeat. So I've got my body. I'll select body 1, which is my propeller. I can turn off other parts of the sketch I don't need anymore. And I'll just do a simple circular pattern repeat. And this is where you get to select how many, what axis and how many propellers you have. Okay, so here I've got 3. So I've gone in, I'll do that one more time. Select the body, pattern repeat. The object is already selected, axis, just click on that. And you can do 5 propellers like we did before, 5 blades, 2 blades. I'm going to stick to my stock standard 3. Okay, and there's our next part there. Okay. Now, just to go a little bit further into editing sketches, you can use that same sketch scale function to go in and, you know, change the shape of your blade further. So I could go in here, I could use that sketch scale function that we went over before to scale it down instead of up, and that will change and add a bit of, you know, an extra kind of element to the design as well. There's no real kind of engineering reason for doing this, but it's something you might want to experiment with. So if I change that down, change that to, 0.9 and not 9, make it a bit smaller, and all it'll create is a little, a bit more of a taper. So you notice if you look from above, there's a bit of a taper on that. If I go in and make that a lot more drastic, the taper will be a lot more drastic as well. Okay, so final thing is to go in, add a sketch to this front part here. And what I want to do is add a circle that grabs all of these inner points, all these inner points here, not at the edge. So that's the reason I did the round there before. So all I need to do is create something that links in all three of these areas. So I'll go circle, I'll go out until I'm just beyond that point there where I've added my cut. Okay, I'll select that circle and I'll extrude it both sides. You'll want to do a two-sided extrusion because you might need to extrude it more at the back or the front, and this will be a join. The function of this is to join all of those bits that we've made together. Okay, so there's the front side, a little bit of tearing there, and I'll grab that down and do the back side as well. So now all of my propeller blades are interlinked with that central part coming through. So I will sketch onto the top and make my axle hole, and I'll just make that 2 mils. If we need to drill it out more, we can. If you want to make it bigger, you can. Yeah, finish that sketch. Select what we've just done, extrude. Instead of distance, I'm going to select to object, but you can go distance if you want. And I'm going to navigate around and select the back side of that join there. So pretty much what that means parametrically is that extrude will go from the top side of the propeller all the way to the back, regardless of how thick that section is. All right, to finish up, let's do a couple of fillets. Because we've designed this the way we've designed it, we don't need to go in and do as much finishing as I thought we would, which is good. So go and add around there. Keep in mind that surface area will affect friction between surfaces of contact. So you want to try and keep it stable so it has something flat to rotate on, but you don't want to take away so much. You don't want to, keep it all flat there. If you can remove material and surface area between contact surfaces, then that's something that you should do for efficiency. I might try and make an attempt at rounding these off too, see if they like it. Sometimes they do, sometimes they don't. No, doesn't like it. So I might do that as a separate fillet. Okay, here. Aerodynamically, it won't have much consequence. I just like to make things look pretty sometimes. So I'll go here. No, doesn't like it. I'll try and change it down a bit if I can. You can choose an edge or a surface for your fillets as well. Sometimes a chamfer is more stable than a fillet. No, it doesn't like me. 0.4, 0.3, 0.2. There you go, tiny, tiny little chamfer there, but yeah, inconsequential, so I won't bother doing it. And that's pretty much the model. one component, and yep, I'll save this as my new propeller. So don't forget our naming conventions. So put in your first or last name, underscore, the model, the item name, and then the version. So this would be MK2 for me. Save that. Then right-click and save as mesh to get my STL file. Export. One object, STL binary, millimeter. Excuse me. And I'll put this in my shared drive. So you'll dump it in. You won't be able to save in the same way. You'll save it in your downloads. And you'll go to Student Propeller Designs and save it there. And that's the tutorial. So thanks for watching, and we'll see how we go in testing.